Hello, friends. Welcome back for another session on system design. In our previous discussions, we explored various techniques for creating scalable distributed systems. Today, we will continue building on that foundation by focusing on the crucial role database plays in enhancing our system design. If you have not seen those videos, then they are available on my YouTube channel under System Design. As you remember, we started our journey by creating a simple client server setup. Our client was able to communicate with the server using DNS. We also learned about load balancer and various techniques which can be implemented by a load balancer to implement horizontal scaling. In this session, we will go over various database techniques involved in a system design. Separating an application tier with a database tier provides a flexibility to scale them independently. If you're attending interviews, then the most common question which you can expect are how will you optimize your database design? How will you scale your database design? And the most important is which database will you choose? Will you choose a SQL or a NoSQL database? Now, there is no one question or one answer for these kind of questions. It always depends upon situations and a lot of other factors which we are going to discuss further in this topic. An experienced developer will mostly go for polyglot architecture during these kinds of interviews. So what exactly is a polyglot architecture? Polyglot architecture is you can use more than one type of database in your design. For example, in this particular case scenario, if you are creating a social media kind of application, you can use a relational database like Oracle or Sybase or MySQL, etc., to store tables or data where a strong relationship is expected, consistency is expected, and asset transactions are expected. You can use Redis wherever the caching is required and low latency data is needed. You can use Apache Cassandra for running big data analytics. You can use graph database like Neo4j to provide a recommendation to users. Similarly, you can implement website search using MongoDB. Now, the purpose of this video is not to deep dive into databases. We will keep our design simple and we will restrict our discussion only to system design point of view. We will use one SQL and one NoSQL database. Now, a basic question involved here is which part of your database will you store on SQL and what will you store on NoSQL database? Technically, you can store anything on NoSQL database. As a rule of thumb, you can use NoSQL for super low latency and unstructured data. NoSQLs are easy to scale, whereas SQL databases require some special algorithms and techniques which we will explore in this session. In our case study, we can implement our system design by putting the tables which contain data related to user profile, authentication, and relationship between users, etc., on the SQL database. We can put the data which contains post, comment, like, reaction, notification, etc., on the NoSQL database. Justification during interviews you can provide is this kind of data which involves user profile, authentication, and various other relationship requires strong consistency to maintain those authentications. And those kind of authentications are maintained using foreign key relationship between the tables. Similarly, to extract those data, sometimes it involves very complex queries. So it is much easier to implement that using a relational database like Oracle or SQL Server or MySQL or any other database of your choice. Similarly, you can provide justification for keeping your post, comments, etc. on the NoSQL database. The reason why NoSQL database is opted here is because this kind of data is either semi-structured or unstructured. Now, I don't want to go into too much detail on NoSQL at this point of time because it will distract us from our main goal of learning system design. But at very high level, you can assume that a structured data is a data where you already know the field and the column names of a table when you're designing your data tables. And unstructured data is when these information is not standard. For example, for one record you may need only two fields like id and post, and for the second record you may need id, post, and some more information. So if your requirement is this, then the data can be placed on NoSQL. The advantage of using this NoSQL is it supports all this semi-structured and unstructured data, and it also does not have the overhead of complex joins. So pretty much NoSQL data will be very fast. Now, after deciding on SQL and NoSQL database, we will look into various optimization and scaling techniques which can be used to improve the performance of our database. The first and the most easiest recommendation to improve the database performance is an hardware upgrade. This is nothing but vertical scaling, where you can opt for a more efficient CPU and more memory, which will naturally improve the performance of your database. One more way we can optimize our database is by implementing a connection pooling. It can be done at a database server level and application level. So we know that every time a user makes a connection to a database, making a connection to a database is a very expensive process. So it can be implemented by maintaining a pool of connections in a server, and every time a client tries to access a database, the connections from the pool will be reused. This way we can improve the performance of our database applications. One more method which we can use to improve and optimize our database is by implementing a cache. Users can store frequently accessed data in a memory. You can also optimize your database by creating efficient indexes. Now, more detail on indexes is out of scope for this discussion, but technically, indexes are like pointers to various locations of your data. And instead of doing a full table scan, if you have indexes, then database will use and utilize those indexes to access the data very quickly, resulting in overall performance of your database. Sometimes it is possible to improve the performance of a data by denormalizing an overnormalized database. For example, in this case, data from these two tables can be accommodated into a single table by removing the unnecessary join between these two tables and resulting the overall performance of the database table. There is one more way you can improve your database optimization is by introducing asynchronous processing. So here you can offload heavy duty tasks on the background jobs. For example, when a client is trying to access database, instead of waiting for this job to finish, which takes more time, the response can be sent very quickly to the client of whatever is available, and rest of the things can be processed behind the screen, and it will keep on coming to the user whenever it is available. Query optimization can also help in optimizing overall database performance. But this is a very subjective topic, so we will not go into too much detail at this point of time. Hash based database sharding is also very popular. You see that it is also helping us to achieve horizontal scaling. So, in this particular scenario, a database or data from this table will be redirected to three different databases based on a product ID. If a modulus of a product ID is 2, then that particular record will be stored in a database which is configured as 2. If a modulus of product ID is 1, it will go into a database which is configured to store data with modulus 1. Similarly, if a data is resulting in modulus 0, then all those records with modulus 0 will be stored in this particular database. So there is no confusion. Every time a new record comes, and if the product ID is either 0, 1, or 2, it will be automatically redirected into that particular database. Just like hash based sharding, range based sharding is also very popular, and it is very easy to implement. In this particular case, we have two databases, and both of them were configured to receive range between certain numbers. For example, this database is configured to receive a range between 101 and 103, and this one is configured to receive a range between 104 and 106. Now, this is just a sample, but in reality, these numbers will be this number will be range will be very large. So, in this case, if 102 comes, which is between this range, it will be redirected to this one. Similarly, if 105 arrives, it is between 104 and 106, so it will automatically go into this database. You can also achieve horizontal scaling with replication. Basically, replication means you can have one or more than one database which will maintain a copy of a master database. In this example, we will look into a single leader replication. In single leader replication, you will have one master database which will be connected to multiple slave databases. Master database will be used for writing operation, and slave databases will be used only for read only operations. Now, the copying between master and slave database could be either synchronous or asynchronous. Let's look into this case scenario. Client A is performing a write operation. It will get updated on the master database, and then it will be updated on all other slave databases. If the connection between or the replication between master and slave are synchronous, then it will be real time, meaning you are updating something here, and this connection will wait until the data gets updated in all slave databases, and then it will be committed. Asynchronous, the data gets committed here irrespective of whether it is getting updated or when it is getting updated on all slave databases. It consider it like a background process. As soon as the data gets updated here, it return back to the client, and then behind the screen, asynchronously, this data will get populated on all other slave databases. If user B and user C have to uh, get the data, and if they only want to read the data, they can query slave databases. Another example is if a transaction has to be performed, it can be done on the master database, but if reports have to be generated, it can be done on the from the slave databases. So this way you can achieve a horizontal scaling and you can optimize your design. Now, another variation of this replication is multi-leader replication. It is also known as master-master replication. Now, here there is no slave database. Every database will be a master database where you can perform read or write operations. And the replication between those databases will be either synchronous or asynchronous based on your design. In this case, client A can perform read and write operation on master database, this one, and it will be replicated on all other database. And when client C has to perform read and write operation, it can choose this database and it will be replicated on all other databases. So basically it is a bidirectional replication. Leaderless replication is also very popular on NoSQL databases. The difference between multi-leader and leaderless replication is there is no leader in this design. A client can send first request to this database and its next request can go to any other databases. And all these databases are replicated bidirectionally. You can also use data centers to scale your applications horizontally. For example, in this particular case, we have distributed our databases in various regions: US, Europe, and Asia. But in your case, you can have multiple region in US itself, like in New York, San Francisco, Philadelphia, so on. The benefit of using this kind of scaling is you can have localized data which is needed sometimes for regulations. For example, if you want to store all your trades which are specific to China in a data center within China so that US cannot access it and vice versa, then this kind of design is recommended. So you can see that you have all the web servers here within a data center which are already horizontally scaled, and then you also have all the databases which are horizontally scaled. And at the global level, you have isolated this data in a specific data center which is different from other regions and nobody can access it. So in this discussion, we have seen how can we optimize our system design using various database techniques. In the next session, we can see how we can optimize it more using various cache technique. Thank you for watching this video. Keep in touch.